Hi, hello. Now, welcome to my Calculus for Beginners. Now, in this session, we will devote our time to obtaining derivatives of algebraic functions. Now, there are several formulas for us to work effectively throughout algebraic expressions, namely their derivatives. Now, we have formulas here listed from 1 to 10 as given by ChatGPT. Now, the first formula here is for a constant, that is 0. Now for a variable x, derivative is 1. And we have a power formula here, wherein x is raised to a power n. All we have to do is bring down the n, and then multiply it to x raised to a power n minus 1. So don't forget, the power has to be less than 1. Okay, how about if we multiply a constant to a function, then the derivative is a constant multiplied by the derivative of the function. Now, if you are wondering how these formulas were obtained, I have a separate video for the calculus tricks that were used in order to obtain these formulas. But for this video, due to a time constraint, we will just enumerate the summary of those derivations. Now here, this is a sum in a where we add or subtract a function g of x from f of x, and turns out that all we need to do is to take the derivative of the functions f of x and g of x. So we have f prime of x plus minus g prime of x. Now how about for number 6, a product of f of x and g of x? So here we have to take the first the derivative of f of x, then multiply it to g of x, and we add it to f of x, and then multiply it to the derivative g of x. Okay, and then what is the seventh formula? It is a quotient, so all we need to do is to square the denominator g of x, and then from g of x we multiply the derivative of f of x as f prime of x, and we subtract it to f of x multiplied by the derivative g prime of x. Now for the remaining numbers 8, 9, and 10, let's just try to reserve that. So for a chain rule, so we'll try to use it later on in the problems, but for now let's try to use the formulas 1 to 7. Those are the most basic ones, and they are very important in mathematics. So let's try to have some exercises, and I have prompt ChatGPT to give us some exercises regarding those basic operations, namely sum, difference, product, quotient, and of course a bit of power rule. So first, let's have some exercise. We must use formula 1, and the formula 1 states that a derivative of a constant is merely 0. So we write 0, and do we get that answer? Yes. Our first derivative, or f prime of x, is indeed 0. Now how about if we take the derivative of x? You might guess that the formula that we need is formula number 2, which states that the derivative of x, or a variable x, is simply 1, meaning it's the slope. So our slope here is 1, and indeed our answer for the first derivative is 1. Now how about here, number 3? As you can see, 3 is multiplied to x raised to a power, so it's x raised to a power of 2. So you might guess that the formula that we need is 3 and 4. So 3 is the power rule, and number 4, we multiply it by a constant. So let's try to solve that, and I will use my note to demonstrate this so that everything is cleared out, so we have 3x squared. Okay, so our problem number 3, so for exercise number 3, we have f of x equals 3 times x squared. And you'll notice that this is just a constant multiplied to a variable raised to a power. Now, the thing is, from the formula, so let's try to familiarize ourselves with the formula. So we have x raised to a power n. So all we need to do here is, for the constant, we just need to multiply it. So here for formula 4, the thing is, multiply the constant, which is 3, to the first derivative of x squared. So our f prime of x is simply, by using the power rule, all we need to do is to bring down the power. So the power here is 2, and then we raise the variable to power less than 1. So 2 less than 1 minus 1. And therefore, our derivative now is 3 times 2 is 6, and this raised to 2 minus 1, or simply x. So that's our solution. And this is the incorporated answer. Did we get it correctly? Yes. That's also the answer given to us by ChatGPT. So f prime of x is equivalent to 6x. By the way, don't be so dependent on the AI. The AI will try to guide you in your studies. But of course, using modern technology, it's not yet that refined. It might yield some faulty solutions. Now the trick is, if you have doubts on the solutions, all you need to do is to type again or ask him again about the problem and try to rephrase it a little bit so that he would again answer it back, and hopefully he will give you a better answer compared to the last prompt. Now for this, I think everything is okay. So I have checked it. So let's proceed now with the fourth exercise. Now the fourth exercise is all about let me write it first. F of x. So let me write it first. F of x equals negative 2x cubed plus 7. So it's the same. So it's the same, almost the same as number 3. So we have a constant multiplied to a power raised to 3. Now all we need to do is, again, bring down the power 3 and then raise it to 3 minus 1. And then of course, the derivative of a constant 7 is 0. So all we need to do now is to multiply negative 2 by 3. So we have negative. And again, our answer is correct. We are in unison with the answer of ChatGPT. That's negative 6x squared. Now 5. Let's proceed. Let's proceed now to exercise number 5. So here we have f of x is equivalent to 1 over x. Now we can try to rewrite this as x raised to negative 1, so that we could apply now the power rule. So transforming it to x raised to negative 1, we can now use the power rule to get the derivative. And as I have said, all we need to do is to bring down the power. This time the power is negative 1. And then we multiply it to x raised to the power, and we have raised to a power less than 1. So subtract 1. Therefore, our derivative now, f prime of x, is equivalent to negative x raised to negative 2. Or simply, the derivative is negative 1 over x squared. So you bring down the power, change the sign, So it's x squared, 1 over x squared. So let's proceed now with number 6. Now here we have f of x. Again, this is an example of a power rule. All we need to do is to transform it to something like x raised to 1 half, because the square root is equivalent to the 1 half. So therefore we have our f prime of x, the first derivative, as I've said, bring down the power, which is 1 half, and then subtract 1 to the power of x. So we subtract 1. Therefore, the first derivative is x raised to negative 1 half. Or we can rewrite it as 1 over 2 square root of x. Effectively, you bring down the 1 half, change the sign, so it's 1 over square root of x. Okay. So I think so far so good. So we proceed now with number 7. Okay. So number 7, so it's also an application of the power rule. So multiplied to a constant. 4x raised to the 5th minus x cubed plus 6x minus 9. So this is the function. So the derivative now, I hope you can follow it already. So that's 4 multiplied by 5, x raised to 5 minus 1 minus 3x raised to 2 minus 1 plus 6x 1 minus 1 minus 0. The derivative of a constant 9 is 0. Therefore, our first derivative is f prime that's equivalent to 20 x raised to the 4 minus 3x squared plus 6. 1 minus 1 is 0, so x raised to 0 is simply 1, so we don't need to write it anymore. So this is the final answer. 20x raised to the 4th minus 3x squared plus 6. It's also the answer of ChatGPT. So here, for the 8th exercise, x equals 6x squared plus 1 half x minus 3. So our f prime of x is simply, again, you bring down the 2, so 2 times 6 is 12. And then we subtract 1 to 2, so 2 minus 1 is just 1, so we don't need to write it anymore. So it's x raised to 1, that's understood already, plus 1 half multiplied by the power of x, which is 1, so it's still 1 half. So how about here, x raised to 1 and we subtract 1, so it's x raised to 0. So that's effectively 1, so we don't need to write that anymore, since it's understood that there's a 1 multiplied to 1 half. So this is the compact form. It's already the answer. So that's it. In the next episodes, we will try to solve more challenging derivatives by applying the we have to apply the product and the quotient rule, so as with more complicated forms of the power rule. So that's it for now, and thank you.